Stand near dry soil when the first drops hit, and the smell shows up almost at once. The ground is barely wet, the cloud has only just arrived, and yet the air suddenly smells earthy, rich, almost alive. That is odd, because rain is mostly water, and water on its own does not explain that smell very well. Most of what you are smelling is not the cloud talking. It is dry ground, plant residues, soil microbes, and tiny splash physics getting thrown into the air. So if we want the real answer, we have to watch the ground become a scent launcher. The first mistake is completely reasonable. The smell arrives with rain, so the mind tags rain as the source. A few drops land, the air changes. Case closed. Except the timing is doing a lot of the lying. What usually happens is that the first moisture arrives at a surface that has been sitting there through heat and dryness. Soil, stone, dusty pavement, garden beds, dry concrete, all of it has been collecting material and holding material. Then the first drops hit, and the smell appears so fast that the whole event feels as if it came straight down from the cloud. That feeling is real, but the explanation is different. Clean rainwater by itself does not usually carry that deep, earthy note people mean when they talk about the smell after rain. The stronger source is often the surface being hit. The cloud starts the event, but the ground supplies much of the character. That is the first reframe to keep in view. Rain is the trigger. It is not the whole cast. This is why the smell can reach you before everything looks soaked. The world does not need to become fully wet first. The first contact is enough to start releasing material that was already waiting at ground level. It also explains why the smell can change from place to place. A dry garden bed does not smell the same as a hot roadside. Porous rock after a long dry spell does not smell the same as a city footpath after a brief shower. If the cloud was supplying one simple universal scent, those differences would be much harder to explain. Instead, the better picture is local. The rain arrives, the surface answers, and the more the surface had stored through dry weather, the more dramatic that answer can feel. The smell does not only belong to weather overhead, it belongs to what the weather has just touched. That makes the ordinary experience a bit stranger. The scent people call the smell of rain is often not really a smell from the sky at all. It is a ground-level release event that happens to be set off by falling water. Once that lands, the next question gets sharper. If the source is mostly down here, what exactly was waiting in the ground before the rain even started? This is where one famous word helps, then quickly becomes a trap. The word is petrichor. People love it because it sounds like a complete answer. You ask why rain smells so good, someone says petrichor, and the conversation feels finished. It is not finished. Back in 1964, two Australian researchers, Isabel Joy Baer and Richard Thomas, coined that word for the smell released when dry soils and rocks are moistened. That origin matters because it points the explanation in the right direction from the start. The word was tied to dry ground meeting moisture, not to some perfume hiding inside pure rainwater. So petrichor is best treated as the broader, earthy after-rain phenomenon. It is the umbrella. Under that umbrella sit several contributors. Dry periods matter because they let surfaces load up. Plant-derived residues can accumulate in soil and rock. Porous materials can hold onto those traces through warm weather. Then humidity rises, droplets arrive, and the surface begins to give some of that material back to the air. That is why the first rain after dryness feels different from rain on ground that has already been wet for days. The smell is tied to a setup condition. The stage has been prepared in advance. This is also where the common shortcut goes wrong. Petrichor is not the name of one monopoly molecule that explains every version of the smell. It is the bigger public label for the experience. Useful word, not final answer. You can think of it as a category with a center of gravity. The center lives in dry ground release. Around that center, different surfaces and different compounds shape the exact result. Some of those compounds come from plants and surface residues. Some come from life in the soil. That second lane matters a lot because once you get into the biology beneath the surface, the smell stops looking like vague weather mood and starts looking like a proper chemical story. So the word petrichor helps if it keeps the whole frame wide enough. It hurts if it makes the explanation sound finished too early. The better use of the word is not "there solved." It is "good, now we know the smell belongs to the ground, and now we can ask what inside that ground is doing the heavy lifting." One of the strongest answers has a name, and it comes from microbes. When people say the smell after rain is earthy, that can sound fuzzy, almost poetic, but part of that earthy note comes from a very real compound with a very real origin: geosmin. Geosmin is one of the strongest mechanistic anchors in this whole story. It is a microbial product associated with that familiar earthy or musty note. Soil bacteria, especially actinobacteria such as streptomyces, are important producers of it. That changes the feel of the ground completely. Dry soil is not just dead dust waiting for water, it is a living chemical environment. Beneath your feet, microbes are making compounds that can later become part of a smell you notice in open air after rain. That is a lovely reversal. The scent feels huge and atmospheric. Part of the source is microscopic and local. Researchers do not treat geosmin as a metaphor. They can trace how it is made. They can identify the kinds of organisms involved. They can even show that human smell receptors respond strongly to it. One receptor, called OR11A1, is especially relevant here. That means the line, "your nose is good at catching this," is not just a casual impression. There is real sensory machinery behind it, and our noses are very good at it. People can detect geosmin at extraordinarily low concentrations. The numbers can get tiny enough to sound silly in conversation, down in the single-digit nanogram per liter range in water studies. The important part is not memorizing the unit. The important part is that trace amounts can still feel obvious. So a very small release can make a strong impression. That helps explain why the smell after rain can seem so rich even when the actual amount of compound involved is small. The nose is not waiting for a thick, visible fog of scent. It can respond to a faint chemical hint and turn that into a vivid experience. There is another boundary worth keeping clean here. Some ecological work suggests geosmin is useful to the microbes that make it. In streptomyces, for example, it appears around sporulation and may help attract tiny soil creatures that spread spores around. That is interesting. It is not the same as saying humans evolved to love petrichor so we could find water, survive drought, or decode the desires of the planet. Human sensitivity is real. A neat evolutionary story about why the smell feels good is much less settled. So the story gives us two strong gains at once. First, part of the smell after rain is biological. The ground is alive, and some of that life is making the molecules involved. Second, the human nose is unusually capable of noticing those molecules. That still leaves one big practical question. Even if the ground is loaded with residues and geosmin, how does that hidden chemistry get from the soil into the air quickly enough to hit you with the very first drops? That is where the raindrop stops being background and becomes the main machine in the story. It is easy to imagine rain as passive. Water falls, ground gets wet, smells sort of drift upwards somehow. That vague version misses the best part. In 2015, researchers studying raindrops on porous surfaces showed a much more specific mechanism. A drop does not just sit there like a tiny puddle. On the right kind of surface, impact can trap little air bubbles inside the droplet. That is the first step. Now picture those bubbles rising through the drop. When they reach the top and burst, they can eject tiny aerosols upward into the surrounding air. Not huge splash droplets you can see, tiny airborne packets. That is the second step, and those aerosols can carry scent-bearing material from the surface. That is the payoff. Suddenly the whole event becomes visible in your mind. The drop lands on porous ground. A bubble forms. The bubble rises. The bubble bursts. A tiny spray goes upward, carrying compounds that were sitting in or on the ground a moment earlier. So the smell gets launched into the air. That one change in language matters, because it matches the physics much better than the usual vague story. The raindrop is acting less like a wet blanket, and more like a microscopic spray nozzle. Or, if you want the blunt version, a scent cannon. That also explains the speed of the experience. People often notice the smell almost immediately, sometimes before the whole street, field, or garden looks properly soaked. If each early impact is making tiny upward aerosol bursts, the fast arrival of the smell stops looking mysterious. The transport is happening right at the moment of contact. This mechanism also helps keep the bigger answer layered instead of mushy. Those aerosols are not carrying one sacred ingredient every time. They can carry a mix. Plant-derived residues, geosmin, and other surface-bound compounds can all be part of the cargo depending on the surface and the conditions. That is why the mechanism matters so much. Without it, the story risks sounding like a glossary. Here is a word, here is a molecule, here is another smell. Good luck. With it, the story turns into a chain reaction. Dry weather loads the surface. Soil life adds one strong earthy contributor. The first raindrops strike. Tiny bubbles form and burst. Aerosols jump into the air. Your nose catches the result. Now the beloved smell after rain has a proper delivery system. It also gives us a better way to think about the first drops. They are not just the beginning of wet weather. They are the moment the hidden chemistry becomes mobile. Once you see that, another familiar detail clicks into place. Some rains smell glorious, some barely smell at all, and some heavy downpours seem to wash the atmosphere flat. So what changes? The best smell often arrives early, not after an hour of hard rain, not after the street has turned into one continuous sheet of water. Often it shows up with the first light or moderate rain after a dry stretch, when the air suddenly changes and the ground seems to answer back. That pattern makes sense once you combine the setup with the launcher. Dry weather prepares the surface. Residues build up. The microbial story keeps ticking underneath. Then the first impacts start ejecting aerosols into air that has not yet been fully rinsed clean of local character. That is the trigger phase, and a heavier downpour can shift the balance. It may still smell like something, but once the ground is getting hammered and washed over, the delicate first release effect can become less distinct. The scene moves from trigger to rinse. That does not mean heavy rain has no smell. It means more rain is not automatically better for this particular earthy note. That is one reason the first shower after a hot, dry spell can feel so dramatic. The conditions favor a strong answer from the surface, and the release arrives before everything turns into one broad wash. The ground itself matters too. A loose garden bed can answer differently from sealed pavement. Porous rock can answer differently from compacted urban soil. Vegetation changes what residues are available. Permeability changes how impacts behave. Wind changes how far the released aerosols drift before they thin out. So the smell after rain is not one rigid formula applied to the whole planet. It is the same core mechanism showing up through different surfaces. That variation is part of why the experience feels familiar and specific at the same time. You recognize the basic after-rain character, yet the smell in a desert town after the first storm is not the same as the smell rising from a city park in summer. Still, the broad pattern holds. Dry spell first, early release next, full washout later. That is the reason the most memorable version often lives in the opening moments of a rain event, when the hidden material has been triggered but not yet thoroughly rinsed or diluted. And now there is one last lane to separate because some people are talking about a different note entirely. Not earthy, not damp soil. Something sharper, cleaner, slightly metallic. That smell can be real too. It just belongs to another part of the storm story. Not every rain smell is the same smell. When people casually say that smell before rain, or the smell of a storm, they can be blending several experiences together. One is the classic earthy ground release smell we have been following. Another can be a sharper, more metallic note associated with electrically active weather. That is where ozone enters. Ozone has a pungent smell, and atmospheric electrical activity can produce it. Lightning and related discharges in thunderstorms are real sources. So if a storm carries that crisp electrical note, ozone is a sensible part of the explanation. But it is a side lane, not the universal reason the first rain smells earthy and rich. This distinction is worth defending because internet explanations often flatten the whole story in one direction or the other. Some stop at Petrichor and never explain the launch mechanism. Some jump to ozone and make it sound as though every beloved after-rain smell is basically a thundercloud running on electricity. Usually, the classic earthy smell people mean is still the ground story, dry surfaces loaded through a rainless spell. Microbial compounds such as geosmin, raindrop impact, bubble burst, tiny aerosols. Ozone can join in when the storm has the right electrical conditions. It can add a different note to the mix. That note may feel cleaner, sharper, almost metallic compared with the rounder, earthy smell rising from soil. So now the taxonomy is finally clean. Petrichor is the broad public umbrella for the earthy after-rain phenomenon. Geosmin is one important microbial contributor inside that broader smell. Ozone belongs to the thunderstorm electric lane and helps explain some storm smells, not all rain smells. Once you separate those lanes, the whole sensory experience gets easier to trust. You are not chasing one magic word anymore. You are holding a layered answer that matches what the nose was telling you all along. Sometimes earthy, sometimes sharp, sometimes both, and with that, the ordinary smell outside your door stops being a vague weather mood and turns into something much more concrete, a release event. Go back to the first drops on dry ground. At the start of this, it felt as if the cloud had brought a scent down with it. Now the picture looks different. The ground had been loading up through the dry spell. Soil microbes had been making part of the earthy note. The raindrop hit, tiny bubbles rose and burst, and the surface sent a faint aerosol plume upward into the air. In some storms, ozone could add a sharper edge, but the classic smell people love was never just plain rainwater announcing itself. It was the ground answering back. That is why the smell after rain can feel so sudden and so alive. For a brief moment, land, life, and impact physics all get turned into air.